Hello and welcome. Good evening to everyone keeping company during this quiet time. Earth continues on its way, following its familiar and steady rhythm. Everything is moving at the pace it should. Nothing is speeding up and nothing is slowing down. The processes at the surface of the planet, in the air and deep below, continue as they have for a long time. The information shared next sits within this same flow. Each part is short, calm and independent, not intended to connect ideas or draw attention, but simply to be presented as it is. Now, this flow will continue. The magnetic field surrounding Earth is generated deep within the planet, far below the surface, where slow and continuous motion occurs in the liquid outer core. This invisible field extends outward into space and forms a protective region around the planet. Streams of charged particles released by the Sun travel constantly through the solar system, and when they reach Earth, the magnetic field alters their paths. Many of these particles are guided away from the atmosphere, while others are gently redirected toward the polar regions. This process helps preserve the stability of the atmosphere over long periods of time. Without this magnetic presence, Earth's surface conditions would be very different, shaped more directly by solar activity. The field itself changes slowly, shifting and adjusting over geological timescales, yet it remains a steady and reliable feature of the planet. Its influence is silent and unseen, working continuously without interruption. At the very center of Earth lies the inner core, a region of extraordinary conditions that differ greatly from anything experienced at the surface. Temperatures in this region are extremely high, yet the pressure is even greater. This immense pressure forces the material within the inner core to remain in a solid state, despite the intense heat. The core is primarily composed of iron, with smaller amounts of other elements arranged in a dense and compact structure. Over vast spans of time, the inner core has grown slowly as the planet has cooled. This gradual process continues at an almost imperceptible pace. The solid nature of the inner core plays a quiet role in shaping the behavior of the layers above it. Although far removed from daily experience, this distant region contributes to the long-term stability of the planet as a whole. Surrounding the solid inner core is Earth's outer core, a layer of molten material that flows slowly and continuously. This movement is not chaotic or sudden, but steady and persistent, driven by heat escaping from deeper within the planet. The liquid iron in the outer core circulates over long periods, creating large-scale patterns of motion. These movements are responsible for generating Earth's magnetic field, linking the deep interior to the space surrounding the planet. The outer core exists under extreme conditions of temperature and pressure, yet it remains fluid due to the balance between heat and compression. Its motion is gradual, unfolding over thousands of years rather than moments. Though hidden far beneath the surface, the outer core is an active and essential part of Earth's internal system, quietly influencing processes far beyond its boundaries. Some of the oldest known materials on Earth are tiny mineral crystals that have survived since the planet's earliest history. These minerals formed when Earth was still young, at a time when the surface was undergoing rapid change. Preserved within certain rocks, they provide rare glimpses into conditions that existed more than 4 billion years ago. Despite countless geological processes acting upon the planet, these minerals endured, remaining intact through immense spans of time. Their composition reveals information about early temperatures, the presence of water, and the development of the crust. Each crystal represents a quiet record of Earth's distant past. The study of these ancient materials helps establish timelines that extend far beyond written history, offering steady and reliable markers in the long story of the planet. The atmosphere surrounding Earth does not end at a sharp boundary, but gradually becomes thinner as it rises higher above the surface. Layers of gases extend outward for hundreds of kilometers, slowly blending into the surrounding space. Near the ground, the air is dense and supports life, while at greater heights it becomes increasingly sparse. Each atmospheric layer has distinct characteristics, shaped by temperature and composition. These layers interact with sunlight, absorb radiation, and influence conditions at the surface. Even at great distances above Earth, traces of atmospheric particles can still be found. This extended atmosphere plays a role in protecting the planet and moderating its environment. Its presence is subtle yet extensive, forming a gentle envelope around Earth as it moves through space. Very large changes have taken place on Earth over immense stretches of time, including periods when a great number of living forms disappeared from the planet. These events unfolded slowly when viewed from a geological perspective, even though their effects were widespread. Layers of rock preserve traces of these transitions, showing shifts in climate, sea level, and atmospheric composition. Life did not vanish entirely during these periods, but it altered its course, gradually giving rise to new forms that adapted to changing conditions. These moments are understood through careful study of fossils and sediments, which accumulate quietly over millions of years. Each layer tells part of a long and continuous history, marked not by sudden endings, but by gradual transformation. The planet itself remained steady and unchanged in its motion, while life adjusted to new balances. Long before the modern arrangement of land and sea, Earth's surface looked very different from today. What are now separate continents were once connected, forming a single broad expanse of land. This configuration existed for millions of years, before slow movement within the planet caused it to change. The landmass did not break apart suddenly, but drifted gradually, carried by forces deep beneath the surface. Evidence of this ancient arrangement can be seen in matching rock formations and fossil records found on distant shores. Over time, oceans widened and new coastlines formed. The memory of this earlier world remains quietly preserved in the structure of the continents as they exist now. The name given to this ancient joined landmass reflects a concept rather than a single moment in time. It represents a long period during which the continents remained connected before beginning their slow separation. During this era, climates and ecosystems followed patterns unlike those of the present day. Plants and animals moved freely across vast stretches of land without the barriers formed by modern oceans. As movement within Earth's interior continued, the land gradually divided, creating the familiar shapes seen on maps today. This process unfolded so slowly that it passed unnoticed by life living upon the surface, leaving behind only subtle traces for later study. Evidence of earlier forms of life has been preserved within Earth's rocks in a quiet and fragmentary way. Bones, shells, and impressions became encased in sediment, protected from decay by layers that built up over time. As pressure increased, these sediments hardened into stone, sealing the remains within. Each preserved fragment offers information about environments that existed long ago, including temperature, water conditions, and available food sources. These records do not tell stories in a dramatic sense, but instead offer steady clues that must be interpreted with care. Through them, a long continuity of life becomes visible, extending far beyond recent history. The surface of Earth acts as a slow-moving archive, storing information about events that unfolded over immense spans of time. Different types of rock form under different conditions, and their arrangement reflects changes in heat, pressure, and movement within the planet. Layers build upon one another gradually, sometimes remaining undisturbed for millions of years. In other places, they are folded, fractured, or reshaped by internal forces. Each pattern records a quiet interaction between surface and interior. When examined carefully, these formations reveal a timeline that stretches back to the earliest stages of the planet's development, offering a calm and continuous record of change. Large bodies of water respond slowly to forces acting upon them, and the regular rise and fall observed along coastlines follows a steady and predictable rhythm. This movement is shaped by distant influences, rather than local conditions alone. Over long periods, shorelines adjust to these patterns, with sediments shifting gradually and coastal forms changing almost imperceptibly. Harbours, estuaries, and tidal flats develop their shapes through repeated cycles that continue without interruption. The timing remains consistent enough to be measured and anticipated, forming a quiet pulse that connects Earth to motions beyond its surface. Although the movement is gentle, its effects accumulate across centuries, subtly shaping the meeting point between land and sea. Alongside this steady rhythm, a broader balance of forces contributes to the same motion, extending its influence across much larger scales. The combined pull of distant bodies creates variations that can be observed over days, months, and longer intervals. These variations are modest, yet they introduce subtle differences in height and timing that repeat in reliable patterns. Coastal environments respond to these changes in slow and orderly ways, supporting ecosystems adapted to regular immersion and exposure. Over geological time, these forces have played a role in redistributing water and energy across the planet's surface, maintaining a gentle exchange between ocean and shore. In regions closer to the polar areas, the sky occasionally displays soft curtains of light that move slowly across the darkness. These displays are not constant, nor do they follow strict schedules, yet they remain governed by underlying physical processes. They appear when charged particles interact with the upper layers of the atmosphere, guided by invisible forces that extend outward from the planet. The colors shift gradually, often forming arcs or waves that drift without urgency. These lights do not alter conditions at the surface, but they serve as a quiet indication of ongoing interactions between Earth and its surrounding space environment. The source of these luminous displays lies far beyond the atmosphere, originating from streams of energy that travel outward across space. When these streams encounter Earth's protective layers, they are directed toward specific regions, where they release energy in a controlled and orderly manner. The process unfolds silently, far above daily activity, and usually passes unnoticed by most life below. Over time, careful observation has revealed consistent patterns in their occurrence, linking them to broader cycles beyond the planet itself. These events stand as calm reminders of Earth's connection to wider systems that operate continuously and without pause. The large bodies of water covering much of the planet play an important role in storing energy over extended periods. Heat absorbed at the surface is distributed gradually through depth and movement, reducing sudden changes in temperature. This slow transfer influences conditions far from where the energy was first received. Air currents respond to these differences, shaping weather patterns that unfold steadily rather than abruptly. Over long spans of time, this capacity for storage and release has helped maintain relatively stable conditions across wide regions. The process is quiet and constant, operating beneath the surface without drawing attention. Across the planet, the presence of vast bodies of water has a steady influence on conditions far beyond the coastlines themselves. Movements within the oceans interact gradually with the atmosphere above, shaping patterns that unfold over days, seasons, and longer spans of time. Warm and cool regions develop slowly, guiding air currents that travel great distances. These processes do not act suddenly, but progress with a measured pace, allowing weather systems to form and dissolve without urgency. The exchange between sea and air continues without interruption, creating a quiet balance that moderates extremes. Over long periods, this interaction has contributed to the relative stability experienced across many regions. The influence remains constant, operating in the background as part of the planet's broader rhythm. In colder regions, large masses of ice have altered the shape of the land in ways that are both subtle and enduring. As these frozen bodies advance and retreat, they move with immense weight and patience, reshaping surfaces beneath them. Rock is worn down, valleys are deepened, and fine material is carried away and deposited elsewhere. This process unfolds over thousands of years, leaving behind smooth contours and broad forms. Long after the ice has withdrawn, the marks remain visible in the landscape. These changes do not announce themselves, yet they stand as lasting records of slow and persistent movement. The land quietly retains the memory of these gradual transformations. At the highest latitudes, expansive fields of ice reflect large amounts of incoming light back into space. This reflection reduces the amount of energy absorbed at the surface, contributing to cooler conditions over wide areas. The presence of ice influences surrounding regions as well, extending its effect beyond its immediate boundaries. Changes in the extent of these frozen areas occur gradually, responding to shifts that take place over extended periods. The reflective nature of ice forms part of a broader balance, interacting with air, water, and land. This balance remains delicate but steady, maintained through continuous adjustment rather than abrupt change. The surface of the planet never remains completely fixed. Even in places that appear unchanged, slow processes are constantly at work. Mountains rise and wear down, Plains form and shift, and coastlines adjust their shape. These changes take place so gradually that they are rarely noticed within a single lifetime. Beneath this calm appearance lies a constant movement driven by internal forces and surface conditions alike. Over immense spans of time, these small adjustments accumulate, producing landscapes that differ greatly from those of the distant past. The surface acts as a living record, shaped continuously without pause or urgency. Wind and water play a central role in this ongoing reshaping, moving material from one place to another with quiet persistence. Rainfall carries particles downhill, streams gather them, and rivers transport them across vast distances. Air currents lift finer material, redistributing it slowly across the surface. None of these actions occur in isolation, and none act with haste. Instead, they combine to produce gradual change through repetition. Over centuries and millennia, entire regions are altered through these gentle processes. The result is not sudden transformation, but a steady evolution that unfolds in silence, maintaining the planet's dynamic balance. Beneath the surface of the planet, the outermost solid layer is not a single unbroken shell, but a collection of large sections that fit together closely. These sections rest upon a softer layer below, allowing them to move with extreme slowness over time. Their motion is measured not in days or years, but across spans that extend far beyond ordinary experience. As they drift, they carry continents and ocean floors alike, altering the arrangement of land and sea. This movement is steady and continuous, even though it may appear imperceptible from the surface. The boundaries between these sections are not fixed lines, but zones where interaction occurs gradually. Over immense periods, their motion has reshaped the planet's exterior, forming the broad outlines of the world as it is known today. The movement of these vast surface sections does not follow a hurried pace. Instead, it unfolds with remarkable consistency, driven by forces originating deep within the planet. Heat rising from the interior sets slow currents in motion, guiding the direction and speed of surface drift. In some regions, the sections move apart, creating space for new material to rise and cool. In others, they press together, producing gradual deformation. These changes take place quietly without announcement and often leave no immediate trace. Yet over millions of years, their effects become unmistakable. Entire oceans open and close, mountain ranges emerge, and coastlines shift position. The planet's surface reflects this long history of movement, recorded in its broad forms rather than sudden events. Where these moving sections interact more directly, stored energy may be released in brief moments of adjustment. Stress builds slowly as surfaces resist movement, accumulating over long periods. When this resistance is overcome, the release occurs, redistributing energy through surrounding materials. The result is a short-lived disturbance that passes quickly, leaving the surface to settle once more. These events are part of the natural adjustment process that accompanies continuous motion. Though their effects may be felt across wide areas, they represent only a small fraction of the ongoing movement occurring beneath the surface. The planet absorbs these adjustments and continues its slow progression without lasting disruption. In certain regions, material from deep below the surface rises gradually toward the exterior. As it ascends, pressure decreases, allowing it to change state. Over time, this material may reach the surface, adding new layers to the outermost shell. The process is neither constant nor uniform, varying according to location and underlying conditions. In some places, it occurs repeatedly over long intervals, building broad features layer by layer. Elsewhere, it remains dormant for extended periods. These processes contribute to the renewal of the surface, balancing the gradual wearing down caused by other forces. Through this quiet exchange between interior and exterior, the planet maintains a dynamic yet steady equilibrium. Across the planet, these interior processes exist in both active and inactive phases. Regions shaped by past movement may remain unchanged for long stretches, while others continue to adjust slowly. Activity does not imply constant motion, but rather the presence of potential change over extended periods. Dormant regions still retain the structures formed by earlier processes, standing as calm reminders of previous activity. Over geological time, areas may shift between states, guided by deep forces that operate beyond immediate observation. This alternation contributes to the planet's long-term balance, allowing change to occur without overwhelming the stability of the surface. The overall effect is one of quiet continuity, sustained through slow and measured transformation. Deep within the planet, the internal structure is arranged in distinct layers, each defined by composition, temperature, and physical state. These layers did not form all at once, but developed gradually as the planet cooled and differentiated over immense periods of time. Heavier materials settled toward the center, while lighter materials moved outward. This slow sorting process established the basic internal arrangement that remains today. Each layer interacts subtly with the others, transferring heat and influencing movement. The boundaries between them are not sharp lines, but gradual transitions where conditions change steadily. This layered structure allows energy from the interior to move outward in controlled ways, supporting long-term stability. Though far removed from the surface, these deep regions shape many of the planet's most fundamental processes. Between the central regions and the outermost shell lies a vast zone of material that behaves neither as a rigid solid nor as a free-flowing liquid. Under intense heat and pressure, this region deforms slowly, allowing movement over long spans of time. It acts as a buffer between the deep interior and the surface, transmitting heat upward while permitting gradual motion above. The material here responds to stress by flowing at an extremely slow pace, measured in millimeters per year. This slow response enables the surface layers to shift without fracturing entirely. Over geological timescales, this behavior plays a central role in shaping the planet's exterior. The presence of this zone ensures that internal energy is released gradually rather than abruptly. The outermost layer of the planet forms a relatively thin shell compared to the vast interior beneath it. Despite its thinness, this layer supports all surface features, including landforms, bodies of water, and living systems. Its thickness varies from place to place, being greater beneath continents and thinner beneath oceans. This variation reflects differences in formation and composition, shaped by long-term processes rather than sudden change. Although thin, this layer is not uniform, containing a wide range of rock types formed under different conditions. It responds to forces from below and above, adjusting slowly to maintain balance. The surface environment depends entirely on this layer, even as it continues to change almost imperceptibly. A force acting constantly at the surface draws objects and materials inward, maintaining cohesion across the planet. This force operates uniformly, influencing oceans, atmosphere, and solid ground alike. It holds gases close to the surface, preventing them from drifting away into space. It also governs the movement of water, guiding rainfall toward rivers and seas. Over time, this influence shapes the overall form of the planet, contributing to its rounded appearance. Although always present, this force acts quietly without variation or interruption. Its effects are observed through consistent patterns rather than dramatic events. The stability it provides allows surface systems to function in an orderly and predictable manner. The same force that holds the atmosphere in place also determines how objects behave at the surface. Materials possess weight as a result of this influence, pressing downward and interacting with the ground beneath them. This condition shapes the structure of soils, the flow of water, and the growth patterns of plants. Over long periods, it affects how landscapes evolve, guiding erosion and deposition. Living systems have adapted to this constant presence, developing forms and processes that rely upon it. Though invisible, its role is fundamental, shaping both the physical environment and the systems that exist within it. The planet's surface remains organized and coherent through this steady influence. Among the planets that circle the Sun, one stands out for having a notably high concentration of mass within a relatively compact volume. This quality gives rise to a strong internal cohesion, influencing how materials behave under pressure. The interior responds to forces with limited compression, maintaining a firm structure even under extreme conditions. This density affects everything from surface gravity to internal heat retention. Over long periods, the distribution of mass has remained stable, contributing to the planet's consistent behavior. The balance between mass and volume shapes internal dynamics in quiet but persistent ways. Though not apparent from the surface, this characteristic underpins many of the planet's deeper processes. Its influence unfolds slowly, supporting a steady internal environment that has endured across vast spans of time. A subtle warming effect operates continuously, arising from the interaction between incoming energy and the surrounding gases. This effect is neither abrupt nor overwhelming, but finely balanced, allowing temperatures to remain within a moderate range. Energy arrives from a distant source and is partially absorbed, partially reflected, and partially retained. The retained portion is released gradually, smoothing out extremes between day and night and across seasons. This process functions without intention or adjustment, governed by physical properties rather than control. Over long periods, it has contributed to conditions that remain relatively stable. The effect does not dominate, but it gently moderates, acting as a quiet regulator rather than a forceful driver. The presence of this moderating process helps prevent rapid swings that would otherwise occur in response to external changes. Heat does not vanish immediately, nor does it accumulate unchecked. Instead, it moves through cycles of absorption and release, maintaining balance through repetition. This steadiness allows surface systems to operate without constant disruption. The process unfolds invisibly, with no clear beginning or end, persisting as long as surrounding conditions remain similar. Its role is passive yet essential, supporting continuity rather than transformation. The resulting stability has persisted across geological eras, adapting gradually as other factors shift. This gentle regulation forms part of the background framework within which surface conditions develop. Not all incoming energy is absorbed. A portion is returned outward, influenced by surface characteristics and atmospheric properties. Light-colored surfaces reflect more, while darker areas absorb greater amounts. Clouds, ice, water, and land each contribute differently, creating a varied pattern of reflection across the planet. This pattern changes slowly as surfaces shift and climates adjust. The reflected energy reduces overall absorption, participating in the broader balance that governs temperature. This exchange does not require precision, but operates through averages that stabilize over time. The interplay between absorption and reflection remains dynamic yet restrained, forming a continuous loop that adjusts without urgency. The proportion of energy reflected back into space affects the long-term distribution of heat. Small changes in reflective properties can influence broader patterns when sustained over long intervals. These influences accumulate gradually, shaping conditions in subtle ways rather than producing immediate effects. The balance between incoming and outgoing energy is maintained through countless small interactions occurring simultaneously. None dominate on their own, yet together they establish a steady state. This equilibrium has shifted slowly across history, responding to changes in surface composition and atmospheric content. The overall process remains calm and persistent, unfolding with no abrupt transitions. Energy reaching the planet arrives primarily from a single distant source, traveling across space before interacting with the upper layers of the atmosphere. This energy does not arrive evenly at all places or at all times, but varies according to angle, distance, and duration of exposure. As it passes through the atmosphere, some portions are absorbed while others continue toward the surface. The arrival of this energy drives many surface processes, including temperature patterns and atmospheric circulation. Its influence is steady rather than sudden, shaping conditions through continuous presence rather than intermittent bursts. Over long periods, the consistency of this energy input has allowed surface systems to develop predictable rhythms. The planet responds not to individual moments of arrival, but to the long-term average of this ongoing exchange. Before reaching the ground, incoming energy interacts with gases, particles, and clouds suspended above the surface. These components influence how much energy is transmitted downward and how much is redirected. The atmosphere acts as a filtering layer, moderating the intensity of energy before it reaches land or water. This interaction does not block energy entirely, but adjusts its distribution. Over time, this moderation contributes to the maintenance of relatively even conditions across large areas. The process operates continuously, responding to changes in atmospheric composition and structure without interruption. Through this steady interaction, the atmosphere plays a central role in shaping surface environments. Beyond moderating incoming energy, the atmosphere also acts as a protective barrier. High-energy radiation arriving from space is reduced as it passes through the upper layers, preventing direct exposure at the surface. Specific gases absorb particular wavelengths, converting potentially harmful energy into less disruptive forms. This protective function does not require constant adjustment, as it is governed by the natural properties of the atmospheric layers. Over immense spans of time, this shielding has remained effective despite gradual changes in composition. The presence of this barrier allows surface systems to function within stable limits. Its role is passive yet fundamental, maintaining conditions suitable for long-term continuity. In addition to filtering radiation, the atmosphere influences temperature by regulating the movement of heat. Warm air rises and cool air sinks, creating slow circulation patterns that redistribute energy. These movements unfold gradually, driven by differences in heating rather than sudden impulses. The result is a continuous exchange between regions, smoothing out contrasts over time. This regulation does not eliminate variation, but it prevents extremes from becoming dominant. Seasonal changes emerge from these processes, following predictable cycles rather than irregular shifts. The atmosphere's role in temperature regulation remains constant, operating quietly above the surface. The composition of the atmosphere is dominated by a small number of gases present in consistent proportions. One of these gases forms the majority of the mixture, providing a stable background against which other components interact. Its presence influences pressure, density, and the behavior of sound and movement within the air. The balance of atmospheric gases has changed slowly over geological history, yet remains relatively stable in the present era. This stability supports predictable physical behavior and consistent interactions with incoming energy. The atmosphere, though invisible, forms a structured and enduring system that envelops the planet in a steady and reliable way. Alongside its dominant components, the atmosphere contains a smaller portion of another gas that plays a crucial role in surface processes. Though present in lesser quantity, this gas participates actively in chemical interactions and energy exchange. It supports processes that occur across land and water, linking air with surface systems in a steady manner. Its concentration has not remained constant throughout the planet's history, but has shifted gradually as conditions changed. Despite these shifts, its presence has remained sufficient to sustain long-term stability. The balance between atmospheric components allows predictable behavior to emerge, creating an environment where interactions unfold smoothly. The atmosphere operates not as a static shell, but as a living system of constant yet gentle motion. Across the planet, conditions vary widely from one region to another, forming distinct patterns that repeat over time. Near the equator, energy arrives more directly, while regions closer to the poles receive it at lower angles. This difference gives rise to broad zones, each characterized by typical temperature ranges and weather patterns. Between these extremes lie regions where conditions shift gradually with the seasons. These zones are not sharply defined, but blend into one another through gradual transitions. Over long periods, they have remained recognizable despite subtle changes. The presence of these zones contributes to the diversity of surface environments, allowing a wide range of systems to exist simultaneously without conflict. Within each zone, air moves in response to differences in temperature and pressure, forming circulation patterns that repeat with regularity. Warm air expands and rises, while cooler air becomes denser and settles. This movement establishes pathways through which energy is redistributed across the surface. Winds develop as part of this process, flowing along predictable routes shaped by rotation and surface features. These movements do not rush, but proceed with measured continuity. Over time, they influence patterns of moisture, cloud formation, and surface conditions. The steady motion of air acts as a linking mechanism, connecting distant regions through slow and consistent exchange. As air circulates, moisture within it undergoes gradual changes of state. Water vapor rises, cools, and condenses into tiny droplets or crystals, forming clouds that drift with prevailing currents. These formations vary in shape and altitude, reflecting conditions within different layers of the atmosphere. The process unfolds quietly, guided by temperature and pressure rather than sudden triggers. When conditions allow, moisture returns to the surface in gentle or sustained forms. This cycle repeats continuously, transporting water between surface and atmosphere. Over extended periods, it contributes to the redistribution of energy and material, supporting balance across diverse environments. The movement of water across the surface follows pathways shaped by gravity and terrain. Streams gather into rivers, which flow steadily toward lower elevations. Along the way, they carry dissolved material and fine particles, altering landscapes through slow interaction. These waterways rarely follow straight lines, instead adapting their courses gradually over time. Their flow responds to seasonal variation, yet maintains continuity even as conditions shift. Over centuries, they carve valleys and plains, leaving behind layered deposits that record their passage. The action is persistent but unhurried, reshaping the surface through repetition rather than force. As water moves across the land, It carries with it fine particles gathered from the surface it passes over. These particles originate from rock, soil, and organic material, loosened gradually by weathering and exposure. The movement is not forceful, but persistent, guided by gravity and the shape of the land. Over time, the accumulation of this transported material becomes significant. Sediment settles where water slows, forming layers that build quietly upon one another. Floodplains, deltas, and gentle slopes are shaped by this repeated process. Each grain follows a slow journey, sometimes traveling great distances before coming to rest. The result is a steady redistribution of material that alters landscapes without haste. This movement links distant regions, carrying traces of one environment into another and recording long-term change through gradual deposition. These flowing pathways do not continue indefinitely across the land. As they progress, they merge, widen, and eventually reach larger bodies of water. The meeting point between flowing fresh water and expansive seas forms zones of transition where movement slows further. Here, carried material settles, contributing to the gradual expansion of coastal features. Over long periods, these processes extend shorelines outward or reshape them entirely. The flow remains constant even as routes shift slightly with time. Seasonal changes may alter volume and speed, but the overall direction persists. This continuous movement forms a quiet connection between high ground and distant basins. The surface of the planet is subtly reorganized through this unbroken exchange, linking interior regions with the margins of the oceans. The height at which the ocean surface rests relative to the land is not fixed. It shifts slowly in response to a range of influences acting over extended periods. Changes in temperature affect the volume of water, while movement of the land itself alters relative positions. These adjustments occur gradually, often over thousands of years, and leave their mark in the form of ancient shorelines and submerged features. The present position represents only a moment within a long sequence of variation. Coastlines adapt slowly, responding to these changes through erosion or accumulation. The overall process lacks sudden transitions, unfolding instead as a series of small adjustments. Through this steady variation, the relationship between land and sea continues to evolve. Within the vast bodies of ocean water, countless substances are held in solution. These materials enter through the gradual breakdown of rock and the movement of water across the land. Over immense spans of time, they accumulate, reaching stable concentrations through balance rather than increase. The composition remains remarkably consistent across wide areas, despite constant circulation. Movement within the oceans redistributes these substances, maintaining uniformity through slow mixing. This chemical presence influences density, movement, and interaction within the water. The oceans act as long-term reservoirs, storing and circulating material without interruption. Their contents reflect a history shaped by steady input and continuous motion, rather than sudden change. Across certain regions of the land, precipitation remains consistently low over extended periods. These areas develop surface conditions shaped by limited water availability rather than abundance. Soil forms slowly, and vegetation adapts to conserve moisture and withstand prolonged dryness. The absence of frequent rainfall influences erosion patterns, leading to distinctive landforms shaped primarily by wind and temperature variation. Despite these conditions, stability emerges through adaptation and balance. The environment maintains continuity, functioning within narrow limits that change only gradually. Over long spans of time, these regions persist, shaped not by extremes, but by the quiet regularity of minimal input. Their presence adds to the diversity of surface conditions found across the planet. In regions where rainfall is frequent and temperatures remain relatively stable, surface conditions support a wide variety of living systems. Dense vegetation develops over long periods, forming layered environments in which countless interactions take place. Growth is steady rather than rapid, shaped by consistent moisture and gradual nutrient exchange. Fallen material returns to the surface, decomposing slowly and enriching the ground below. This continuous cycle unfolds without interruption, supporting complexity through repetition rather than intensity. The environment remains balanced through constant adjustment, maintaining productivity across long spans of time. These regions do not depend on sudden abundance, but on reliable patterns that repeat with quiet regularity. Large areas of land are covered by plant life that interacts continuously with the atmosphere. Through slow chemical processes, gases are exchanged between surface and air, altering composition in subtle but important ways. Leaves and stems respond to light and moisture, adjusting their activity according to conditions that shift gradually through the day and year. This exchange does not draw attention, yet it occurs everywhere. Vegetation is present. Over long periods, the cumulative effect becomes significant, influencing atmospheric balance and surface chemistry. The process remains steady and distributed, with no single location dominating the outcome. Plant-covered regions act as quiet participants in larger systems that operate across the planet. The ground beneath these environments provides structure and support, forming through the slow breakdown of rock and the accumulation of organic material. This surface layer develops gradually, shaped by climate, parent material, and time. It holds moisture, stores nutrients, and anchors living systems in place. Changes occur slowly, influenced by biological activity and physical forces acting together. Though often overlooked, this layer represents a complex and dynamic interface between solid ground and life above. Its formation requires patience, measured in centuries rather than moments. Once established, it continues to evolve quietly, responding to subtle shifts rather than abrupt disturbance. Across the planet, living systems display remarkable variety, shaped by differences in climate, terrain, and available resources. This diversity did not arise suddenly, but developed through long sequences of gradual change. Species adapted incrementally to local conditions, forming networks of interaction that persist through balance rather than dominance. These systems remain dynamic, adjusting continuously as conditions shift. Stability emerges not from uniformity, but from the presence of many interconnected forms. Over long periods, this diversity has contributed to resilience, allowing systems to continue functioning despite variation. The result is a surface environment characterized by quiet complexity and sustained interaction. At the foundation of these living systems lies a dependence on liquid water. This substance moves freely across the surface, dissolving materials and enabling chemical processes to occur. Its presence allows transport, reaction, and exchange to proceed at a measured pace. Without it, many surface interactions would slow or cease entirely. Water does not act alone, but as part of broader cycles that connect atmosphere, land, and living forms. These cycles repeat continuously, maintaining balance through circulation rather than accumulation. The availability of liquid water has remained a defining feature of surface conditions, supporting continuity across immense spans of time. Living systems on the planet are not confined to a single setting, but extend across land, water, and the air immediately above the surface. Each of these environments supports different forms of activity, yet they remain closely connected through continuous exchange. Materials move from land into water. Gases pass between surface and atmosphere, and organisms shift gradually between these zones over time. Boundaries exist, but they are not rigid, allowing interaction to proceed without interruption. Changes within one environment often influence conditions in another, creating a network of relationships that unfolds steadily. The result is not a collection of isolated regions, but a unified system in which movement and interaction occur quietly and persistently. This interconnectedness allows continuity to emerge through balance rather than separation. The long span of time over which surface conditions have remained relatively stable has allowed increasingly complex arrangements to develop. Simple interactions gradually gave rise to more intricate patterns, shaped by repeated processes rather than sudden change. Each new layer of complexity built upon what already existed, responding to conditions that shifted slowly and predictably. Stability did not imply stillness, but rather a capacity to adjust without losing coherence. Over immense periods, this continuity supported the emergence of varied structures and interactions, each adapted to local circumstances. The progression was incremental, unfolding without urgency, guided by persistent conditions rather than rapid transitions. This extended duration provided the foundation for systems capable of sustaining themselves through balance and adaptation. Conditions at the surface have never remained entirely constant, but have shifted gradually in response to a range of influences. Temperature, atmospheric composition, and circulation patterns have varied over long intervals, producing periods of relative warmth and coolness. These changes did not occur abruptly, but followed slow trajectories shaped by multiple interacting factors. Evidence of these shifts is preserved in ice, rock, and sediment, forming records that extend far into the past. Each change unfolded within a broader context of continuity, allowing systems to adjust incrementally. The overall pattern reflects variation within limits, rather than instability. Through this steady modulation, surface environments have continued to function without interruption across vast spans of time. Alongside gradual change, recurring patterns operate on regular cycles that influence surface conditions. These cycles arise from interactions between movement, energy distribution, and internal dynamics. Their effects repeat over predictable intervals, shaping conditions in consistent ways. Although individual cycles may overlap or vary slightly, their combined influence remains orderly. Over long periods, these repeating patterns contribute to the maintenance of balance, preventing extremes from persisting indefinitely. The presence of cycles introduces rhythm rather than disruption, allowing change to occur within a structured framework. This rhythm supports continuity, guiding variation through repetition rather than randomness. Above the surface, the arrangement of visible features in the night sky shifts slowly over the course of the year. Patterns change as position and orientation alter relative to distant reference points. These changes follow predictable paths, repeating annually with minor variation. The movement is gradual, unfolding without urgency, and remains largely unaffected by surface activity. Over long periods, careful observation reveals consistency within this motion, linking surface experience to broader spatial relationships. The changing arrangement does not influence daily conditions directly, yet it reflects the steady progression of motion through space. This quiet shift provides a backdrop of continuity, marking the passage of time through subtle and regular change. Across the surface of the planet, a steady alternation between light and darkness unfolds with quiet regularity. This alternation does not depend on surface conditions, weather or season, but follows a constant rhythm rooted in the planet's motion. As one region gradually turns away from the light source, illumination fades evenly rather than abruptly. Shadows lengthen, temperatures adjust, and surface activity settles into a different phase. Elsewhere, light returns just as gently, spreading across land and water without haste. This cycle repeats continuously, shaping daily patterns in temperature and atmospheric movement. Over long periods, surface systems have adapted to this rhythm, aligning processes with predictable intervals. The alternation remains reliable, offering a stable framework within which change occurs slowly and without disruption. The motion responsible for this regular alternation proceeds at a consistent pace, completing each cycle within a familiar span of time. This movement is smooth rather than uneven, with no sudden accelerations or pauses. It has remained remarkably stable across immense periods, varying only slightly due to gradual influences. The continuity of this motion allows surface systems to synchronize with its timing, forming patterns that repeat with dependable regularity. Even subtle processes respond to this steady pace, adjusting gradually rather than abruptly. The persistence of this motion contributes to the predictability of surface conditions, reinforcing balance through repetition. Though unnoticed in moment-to-moment experience, its influence is constant and far-reaching. The orientation of the planet's axis introduces an additional layer of variation into surface conditions. This orientation is not perfectly upright, but inclined at a modest angle relative to its path. As a result, different regions receive varying amounts of energy over the course of a year. These differences unfold gradually, producing extended periods of change rather than sudden shifts. The inclination remains stable over long intervals, allowing patterns to repeat with consistency. Surface systems respond to these slow transitions, adjusting activity levels in measured ways. The effect is not dramatic, but cumulative, shaping broad patterns through steady variation. This inclination acts as a quiet modifier, introducing rhythm without instability. As the planet follows its path through space, this inclination gives rise to repeating cycles that affect large regions over extended periods. These cycles do not begin or end sharply, but blend smoothly from one phase into the next. Temperature, light distribution, and atmospheric circulation adjust gradually, maintaining continuity throughout the transition. The predictability of these cycles allows surface systems to operate within known limits, responding incrementally rather than reactively. Over long spans of time, this regularity has supported the persistence of stubble patterns. The cycles function as a framework, guiding variation through repetition rather than surprise. Their presence introduces order into change, reinforcing steadiness across the surface. The journey completed along this path follows a near-circular course, returning the planet to familiar positions at regular intervals. This motion proceeds without sharp deviation, maintaining a consistent relationship with surrounding space. Small variations occur, but they unfold slowly and predictably, exerting subtle influence rather than abrupt change. The completion of each circuit marks a return to similar conditions, though never exactly the same as before. Over immense spans of time, this repeated journey has provided a stable backdrop for surface processes. The path remains steady, supporting continuity through repetition and balance. Its quiet persistence contributes to the long-term reliability of surface conditions. As the planet continues along its regular path, the distance separating it from its central source changes slightly over the course of each complete journey. This variation is subtle and unfolds gradually, producing no sudden shifts in conditions. At one point along the path, the separation becomes modestly smaller, allowing energy to arrive with marginally greater intensity. This change does not announce itself at the surface, nor does it disrupt ongoing processes. Instead, it blends quietly into existing patterns, contributing to small differences that are absorbed by broader systems. The approach and retreat occur smoothly, governed by predictable motion rather than irregular influence. Over long spans of time, this gentle variation has remained consistent, reinforcing the stability of surface environments through repetition rather than contrast. Later along the same path, the separation increases again, reaching a point where the planet is slightly farther away than average. The reduction in received energy is minimal, yet measurable when observed over extended periods. Surface systems respond gradually, adjusting without interruption or imbalance. Temperature patterns remain within familiar limits, shaped more by orientation and circulation than by distance alone. This outward portion of the journey passes quietly, leaving no abrupt trace in daily experience. The motion continues steadily, carrying the planet onward without pause. The regularity of this variation contributes to the overall predictability of long-term conditions, allowing surface processes to proceed without disruption. Throughout this journey, the overall shape of the path remains close to circular, avoiding extreme elongation. This near uniformity ensures that changes in distance remain modest and evenly distributed. The absence of sharp variation supports continuity, preventing dramatic shifts in energy input. Over immense spans of time, this stability has allowed surface systems to evolve within reliable bounds. The path repeats with little deviation, offering consistency through gentle repetition. Minor variations occur, yet they remain part of a broader pattern that unfolds without urgency. The near circular nature of the motion acts as a quiet, stabilizing influence, reinforcing balance rather than introducing uncertainty. A large portion of the planet's surface is covered by expansive bodies of water that move slowly in response to gravity and rotation. These waters do not remain still, but circulate through patterns shaped by temperature differences and the form of the ocean basins. The movement is continuous yet unhurried, unfolding over long intervals. This circulation redistributes energy absorbed at the surface, carrying warmth from one region to another. The process moderates extremes, allowing conditions to remain relatively even across wide areas. Over extended periods, these movements have contributed to the persistence of stable environments. The oceans function as reservoirs and pathways, supporting balance through steady motion rather than abrupt change. Beyond these vast waters, the remaining surface consists of solid land masses arranged in varied forms. These regions rise above sea level in shapes shaped by long-term interaction between internal forces and surface processes. Plains, plateaus, and elevated areas develop gradually, responding to movement below and erosion above. The distribution of land and water influences circulation patterns in both atmosphere and ocean, linking surface features to broader systems. Changes occur slowly, allowing landscapes to adjust without interruption. The contrast between land and water adds complexity to surface conditions, yet remains governed by the same steady processes that operate across the planet. Together, these features form a balanced surface that evolves through continuity rather than sudden transformation. Across the surface of the planet, the largest bodies of salt water are arranged into a small number of immense basins that together cover much of the globe. These expanses are not uniform in depth or temperature. Yet they are linked through continuous circulation that unfolds over long periods. Each basin has developed distinct characteristics shaped by surrounding land, prevailing winds, and long-term movement of water. Despite these differences, they remain connected, allowing material and energy to pass gradually from one region to another. The boundaries between them are defined more by convention than by physical barriers, as water moves freely across broad passages. Over time, these vast expanses have influenced surface conditions far beyond their immediate limits. Their presence contributes to the moderation of temperature, the shaping of weather patterns, and the long-term stability of surface environments. The scale of these waters introduces a sense of continuity, operating quietly and persistently without interruption. Rising above these waters are large, continuous stretches of land that form the primary divisions of the planet's solid surface. These land masses differ widely in shape, size, and internal structure, reflecting the long history of movement and change beneath them. Each has developed its own combination of terrain, climate, and surface features through gradual processes rather than abrupt events. Although separated by water, these regions share underlying similarities shaped by the same fundamental forces. Their outlines have shifted slowly over time, carried by movement deep below the surface. The present arrangement represents only a moment within a long sequence of change. Together, these major land areas support a wide range of surface systems, contributing to the planet's overall diversity while remaining part of a single connected whole. Within these broad land areas, certain elevated features rise gradually above their surroundings, shaped by long-term interaction between internal movement and surface processes. These elevations did not appear suddenly, but formed through steady accumulation and adjustment over immense periods. Pressure from below lifted material upward, while exposure at the surface gradually altered its form. Over time, these elevated regions became prominent landmarks within their surroundings. Conditions at such heights differ from those at lower elevations, influencing temperature, air movement, and surface stability. Despite these differences, the formation and persistence of these features reflect continuity rather than disruption. Their presence stands as a quiet record of the slow forces that shape the surface, maintaining form through balance rather than forceful change. Far beneath the surface of the water, the planet's exterior reaches depths that contrast sharply with its highest elevations. These deep regions developed gradually as surface material shifted and settled over long spans of time. Movement within the planet created broad depressions that were later filled by water, forming deep basins that extend far below surrounding areas. Conditions at such depths differ greatly from those at the surface, including pressure, temperature, and light availability. Despite these extremes, these regions remain part of the same continuous surface system. Their formation reflects the same slow processes that shape elevated areas, operating through steady movement rather than sudden collapse. The presence of such depth adds balance to the overall form of the surface, complementing areas of elevation through contrast that remains stable over time. Near the extremities of the planet, extensive areas remain covered by long-lasting ice that persists through extended periods. These frozen regions are shaped by consistent conditions rather than brief events, accumulating gradually as snowfall exceeds melting. The ice forms broad caps that rest upon land and water alike, altering surface reflectivity and influencing surrounding regions. Movement within these frozen masses occurs slowly, guided by gravity and internal pressure. Over time, their extent has varied, expanding and contracting in response to gradual shifts in conditions. Despite these changes, the presence of ice at high latitudes has remained a defining feature. These regions contribute to surface balance by reflecting energy and storing water in solid form. Their persistence reflects stability, achieved through long-term equilibrium rather than abrupt change. In the space surrounding the planet, a single companion follows a steady path, remaining bound by a constant gravitational relationship. This companion does not wander freely, nor does it arrive or depart unexpectedly. Its presence has been continuous across immense spans of time, shaping subtle rhythms at the surface below. Movements of water respond to its pull, rising and falling in regular patterns that repeat without urgency. The relationship remains stable, governed by balance rather than force. Over long periods, this quiet partnership has influenced surface conditions in ways that unfold gradually and predictably. The companion's motion is smooth and consistent, forming a background presence rather than a point of focus. Its influence is woven into surface processes so deeply that it operates without drawing attention, supporting continuity through steady interaction rather than change. Long before surface conditions even reached their present form, the planet itself emerged from material that gathered slowly within a developing system. This formation did not occur in a single moment, but unfolded through countless interactions among particles moving in shared paths. Heat, motion, and gradual accumulation shaped the early body, allowing it to grow and organize internally. Over time, layers developed as heavier material settled inward, and lighter material remained closer to the exterior. Cooling proceeded gradually, enabling the surface to stabilize and solidify. The passage of time involved here extends far beyond ordinary scales, measured in billions of years rather than generations. The planet's present structure reflects this long and patient history, bearing the imprint of processes that operated steadily without interruption. What exists now is the result of continuous development, rather than sudden appearance. Within a larger arrangement of bodies moving around a central source, the planet occupies a particular position that remains consistent over time. This position is neither the closest nor the most distant, but lies within a range that supports balanced interaction with surrounding space. Movement along this shared path proceeds in harmony with neighboring bodies, each maintaining its own course while contributing to the overall structure. The arrangement remains orderly, governed by predictable motion rather than chance. The planet's placement within this system influences the amount of energy received and the pace at which surface processes unfold. This position has remained stable across vast periods, allowing conditions to develop within familiar limits. The broader system provides context rather than disruption, framing surface experience within a steady spatial relationship that changes only gradually. The overall form of the planet departs slightly from perfect symmetry, shaped by continuous motion rather than static balance. Rotation introduces subtle differences between regions, causing a gentle outward adjustment along one axis. This effect does not distort the surface dramatically, but produces a form that reflects ongoing movement. The result is a shape that remains smooth and cohesive, yet subtly adjusted by internal and external forces. Over long periods, this form has remained consistent, supported by the balance between gravity and motion. The deviation from perfect uniformity does not disrupt surface conditions, but instead reflects the planet's dynamic nature. This shape represents equilibrium achieved through movement rather than stillness, maintaining stability through continuous adjustment. Measurements taken across the surface reveal slight variation depending on direction, reflecting the influence of rotation and internal structure. Distances measured around one axis differ modestly from those measured along another, though the difference remains small when considered against the planet's overall scale. This variation does not affect daily experience, yet it illustrates the subtle ways in which motion shapes form. The planet maintains coherence despite these differences, functioning as a unified body rather than a collection of separate parts. Over time, these dimensions have remained stable, changing only through the slow influence of internal and external forces. The consistency of these measurements supports predictable behavior across surface systems, reinforcing continuity through subtle balance rather than exact symmetry. Across the planet's surface, a wide variety of forms appear in gradual transitions rather than abrupt boundaries. Elevated regions give way to flatter expanses, which then slope gently toward lower areas, shaped by long-term interaction between movement below and processes above. These forms did not emerge suddenly, but developed through steady adjustment over immense periods. Pressure from beneath lifted some regions, while erosion reduced others, producing a balanced range of surface features. Each form reflects the same underlying forces acting in different ways depending on location and conditions. The variety does not disrupt continuity, but instead adds subtle complexity to the overall surface. Over time, these features have remained recognizable even as they continue to change slowly. The landscape presents a quiet record of interaction rather than a series of isolated events. Encasing the planet is a layered envelope that changes gradually with height, each layer defined by distinct conditions. Near the surface, the air is dense and actively interacts with land and water. Higher up, it becomes thinner, responding more directly to incoming energy and motion through space. These layers do not exist as rigid divisions, but blend smoothly into one another. Each contributes in its own way to surface stability, either by moderating temperature, filtering energy, or guiding movement of particles. Over long spans of time, the structure of this envelope has remained largely intact, adapting slowly to changes without losing coherence. The layered nature of this surrounding system allows it to perform multiple roles simultaneously, maintaining balance through quiet cooperation. Within one of these upper layers, a specific component absorbs a portion of incoming energy before it can reach lower levels. This absorption occurs consistently, governed by the properties of the particles involved rather than by surface conditions. The presence of this component reduces the intensity of certain forms of radiation, limiting their influence at the surface. Over time, this process has contributed to maintaining conditions within a stable range. Changes in the concentration of this component have occurred gradually, influencing surface environments over extended periods rather than moments. The process operates continuously and without interruption, forming part of a broader system that regulates interaction between space and surface. Its role remains subtle, yet essential to long-term continuity. The absorption that takes place within this layer alters the distribution of energy rather than eliminating it entirely. Energy is transformed and redirected, becoming part of a broader circulation that unfolds gradually. This transformation does not draw attention, but it influences surface conditions in quiet and persistent ways. The interaction between incoming energy and atmospheric components results in moderated exposure rather than sudden impact. Over long periods, this moderation has allowed surface systems to develop within predictable limits. The process unfolds invisibly, guided by physical properties rather than adjustment or control. Its steady operation contributes to the overall balance that characterizes surface conditions across the planet. The position of the planet within its broader spatial context allows certain conditions to persist over long durations. Distance, motion, and orientation combine to support a balance between incoming energy and surface response. None of these factors acts alone, but together they establish a range within which surface processes can operate steadily. This position has remained consistent across immense spans of time, changing only gradually as part of larger patterns. The result is not perfection, but reliability, allowing systems to function without frequent disruption. The broader context provides stability rather than constraint, framing surface experience within gentle limits. Through this balance, long-term continuity has been maintained without the need for abrupt correction. Over immense spans of time, conditions at the surface have remained suitable for continuous activity rather than interruption. Interactions between air, water, land, and internal processes have unfolded within limits that allow long-term persistence. These conditions did not arise suddenly, nor have they remained perfectly constant, but they have stayed within a range that supports ongoing balance. Small adjustments have occurred repeatedly, each absorbed into broader systems without causing instability. The surface environment reflects this long continuity, shaped by processes that favor gradual change over abrupt disruption. The result is a setting in which interaction can continue without reaching extremes that would halt development. Stability here does not imply stillness, but rather the capacity to maintain function through steady adjustment over vast periods. Within this stable setting, a wide array of interactions has taken place, linking physical processes with chemical and biological activity. Materials move between states, energies shift form, and structures emerge through repetition rather than design. These interactions are not directed toward a specific outcome, yet over time they produce organized patterns. The persistence of such activity depends on the continued availability of key conditions that remain reliably present. Changes occur, but they do so slowly enough to allow adaptation rather than collapse. This long-term balance has enabled continuity across eras marked by variation rather than interruption. The surface reflects an environment shaped by endurance rather than intensity. The processes that operate across the surface do not exist in isolation, but are influenced by deeper forces that continue to act quietly beneath. Heat flows outward, materials circulate, and movement persists within the interior, all contributing indirectly to surface stability. These influences rarely make themselves known directly, yet they underpin many surface conditions. The connection between interior and exterior unfolds without urgency, guided by long-term exchange rather than sudden release. Over extended periods, this relationship has remained intact, supporting surface environments through steady input and gradual response. The planet functions as an integrated whole, with each layer contributing to the persistence of the others. Across the vast record preserved in surface features and internal structure, no other known example has yet been confirmed to share the same combination of long-term conditions. While many environments exist elsewhere, the specific balance observed here remains distinctive. This uniqueness does not arise from a single factor, but from the interaction of many elements working together over immense spans of time. The result is not perfection, but sufficiency, allowing processes to continue without frequent interruption. The absence of confirmed parallels highlights the particular arrangement present here, shaped by chance, motion, and persistence rather than design. This distinction remains a matter of observation rather than emphasis, noted quietly within a broader context. The continuity observed across the planet's history reflects an unbroken sequence of change guided by balance rather than extremes. From its earliest formation through countless gradual adjustments, the surface has remained part of a system capable of sustaining ongoing interaction. Each stage built upon what came before, altering conditions without erasing them entirely. The present state represents only one moment within this long sequence, shaped by processes that continue without pause. The planet remains active, responsive, and stable through the same quiet mechanisms that have operated across its entire history. This persistence stands not as a conclusion, but as part of an ongoing progression that unfolds steadily, without urgency and without end. As this sequence of quiet observations comes to rest, there is no sense of arrival or finality. The details shared do not gather into a conclusion, nor do they point toward a single idea. They remain simply as they are, part of a broader and continuing whole. The planet described throughout these moments does not pause, reflect, or change course. It continues, as it always has, within the same slow and measured rhythm. The processes that shape the surface carry on beyond this point, unfolding without regard for beginnings or endings. Movement within the interior persists, unseen and unhurried. Above, the atmosphere continues its steady circulation, adjusting gradually to patterns that repeat without emphasis. Water flows, settles, and rises again, following paths shaped long ago and still quietly maintained. Nothing introduced here requires completion. Each fact exists independently, yet remains connected through time and balance. Together they form neither a message nor a lesson, but a calm arrangement of observations. These details do not compete for attention. They rest alongside one another, evenly weighted, allowing the broader picture to remain smooth and uninterrupted. The planet's surface remains active, though never hurried. Landforms adjust slowly, climates shift within narrow ranges, and cycles continue to repeat. There is no marked transition from one state to another, only gradual movement within familiar limits. What changes does so quietly, absorbed into systems that have long been accustomed to adjustment. As the narration eases away, nothing needs to follow it. The wider rhythm remains intact, unaffected by silence. The same exchanges continue between air, water, and land. Motion carries on at the same pace, guided by balance rather than intention. The sequence ends not because something is finished, but because there is no need to continue speaking. What remains is not a final thought, but an ongoing presence.